Today we're doing graphing quadratic inequalities in two variables. We're going to learn how to graph the quadratic inequalities, then we're going to learn how to solve some quadratic inequalities using tables and graphs. First of all, to graph a quadratic inequality, we have three real main points. First of all, we have to graph the parabola that defines the boundary. Remember, with inequalities we have boundaries. When we did linear inequalities, we had boundary lines. With quadratic inequalities, we have boundary parabolas. So we have to graph the parabola, and how we've learned how to graph parabolas, we've learned many ways, but the one we're going to use today is first we find the axis of symmetry, which is negative b over 2a. Then we plug that value back into the equation to find our vertex. And then we find the y-intercept. So using the vertex and the y-intercept, we'll have our boundary line. Solid parabola when it's greater than or equal to and less than or equal to, and a dashed parabola when it's less than or greater than. Here's our example. This says y is greater than your equation. So I did a solid parabola. I'm sorry, this is y is less than. I have a solid parabola and I shade everything below it when it's less than or equal to. If it were greater than or equal to, you would shade everything inside the parabola and up. Okay, let's try an example. Y is less than negative 2x squared minus 4x plus 6. Find your axis of symmetry. X equals negative b over 2a. Negative b over 2a gives us negative 1. Plug that back into your equation. You get 8 for your y value, so your vertex is negative 1, 8. Negative 1, 8. Y-intercept is 6, right there. We graphed a dashed line and shaded everything below it, which ends up being inside. Let's try another one. Y is greater than or equal to 2x squared minus 5x minus 2. We get our axis of symmetry, which ends up being an improper fraction. The improper fraction will be easiest to do your math with. The mixed number is going to be easiest for you to graph with. So I kept 5/4, replaced that with x, and did the calculation. Negative 41 over 8, your mixed number is negative 5 1/8. The negative 5 1/8 is going to be easiest for you to graph with. Your vertex, graphed right there. Your y-intercept is negative 2. It opens up. So I did a solid line and shaded everything above the parabola because it's greater than or equal to. Last example. Y is less than 2x squared minus 4x minus 2. Axis of symmetry, negative b over 2a, gives us 1. Plug that back into the equation and we get negative 4. So our vertex is 1, negative 4. Our y-intercept is right there, negative 2. Here we graph 1, negative 4, negative 2, do a dashed boundary line, and shade everything below because it's less than. All right, now let's solve some quadratic inequalities using tables and graphs. Using tables and graphs means we're going to use our graphing calculator because the tables are in there for us and it makes it nice and neat and easy. But for a quick reminder, for and statements, both conditions must be met because they're inequalities. For or statements, at least one condition must be true, must be met. So our first example here, we have x squared minus 6x plus 8 is less than or equal to 3. So it's an inequality. You have a quadratic equation is less than a linear equation. So graphically, this is what it looks like. I've shaded in blue here where it would be less than or equal to. We're not going to be graphing for our assignment, but I just wanted to show you graphically what it looked like. So what we do is we set y1 equal to the left side of the equation and y2 equal to the right side. We actually plug that into our graphing calculator under y1 and y2. y1 has to be less than or equal to y2. And then you just hit second table, and it shows the table of all the values, the x inputs and the y outputs. So x, y1, and y2 is what your table in your calculator will look like. And y1 must be less than or equal to y2. So I look at my y values and I look for where they're less than or equal to, which I have colored in the blue box. It's easiest to do a number line at this point to figure out how to write your answer. So I put a closed dot at 1 because that's equal to, and a closed dot at 5 because that's equal to. And everything in between is part of the solution. So 1 is less than or equal to x is less than or equal to 5. That's your final answer. Next example. Same equations. I'm just going greater than. So y1 and y2, they're all the same. They're already in your calculator. Everything here is the same. Graphically, that means that your answer is above the x equals 3 line. I'm sorry, the y equals 3 line. Same exact table, except we want to go where y1 is greater than y2. Here is why y1 is greater than y2, where x equals 0 and smaller. Greater than where x equals 6 and bigger. But interestingly enough, I did not put my dot at the 0. I did not put my dot at the 6. Okay, if I have an x value of 1, my y values are equal, and that's not part of the solution. But what if x is 1.1, 1.5, 1.9? Okay, x cannot be 1, but it can be bigger than 1. That's why I did the open dot at 1. I'm sorry, smaller, goodness, and everything's smaller. Here, x cannot be 5, because that makes the y's equal, but it can be everything bigger than 5. So not including 5, but everything bigger. Okay, 2 more examples. A new inequality, y1 and y2. So you set in your calculator, y1 is the left side, y2 is the right side. And we just have to look for where y1 is less than y2. Second table, this is what your calculator will point out, will calculate for you. We look for where y1 is less than y2. Right here, less than, less than. Those are equal to, bigger than, those don't work. Equal to, bigger than. Number line helps out a lot. So if I plug in a -1, my answers are equal, which is not acceptable. But a 0 is. So that's why I circle the -1, because I want to include everything bigger than the -1 but not including it, or smaller than the 2 but not including the 2. So we have an answer. Last example. Same equations, just a different inequality. Same setup, same table. We just have to read the table in a different way. Okay, y1 is greater than or equal to y2. Equal to, greater than. Equal to, greater than. Number line is much easier. Dot at -1 and 2. Bigger, smaller, we have an answer. That was our last example for that one. Next we're going to learn how to solve quadratic inequalities using algebra.